hard drive or whatever. All right, let's do another one together. Let's crank it up. Y'all cooked it that way better than I expected. I even stopped and thought about how to explain it to you to kind of make, but y'all did really well. Let's do we're gonna do this to let's revolve it around X and then let's revolve it around let's go ahead and revolve around Y. Because I think Miss Horton wants us in there at 9, and I need to show you around another axis. And let's see what happens and how it's different. Graph them first. It's always good to get a good picture. That helps me anyway. X cubed, and I'm going to go ahead and say the cube root of y is x because I know I'm doing it in terms of y here on this one. And then I am going to do do they all overlap? Yes, they do, but it's closer down to the, I didn't draw it very accurately. Because they're both going to share 1, 1. But the cubed, let's see. Should do something. I know that that is completely inaccurate. It's hard to see. X cubed should be on the bottom. That's what yeah. All right, so it's this little, no, x cubed should be on the bottom. Did I have it on the bottom? Yes, because this is, okay. All right, I've got this little shape. This one is x cubed. This one is square root, or x squared. Sorry. It's teeny. You really have to zoom in to see it. Yeah. So it's, and I'm thinking like, because 1/2 squared is 1/16. 1/2 cubed would be, no, 1/2 squared would be 1/4. 1/2 cubed would be 1/8. 1/8 is smaller than, so the cubed is going to be below. So really my shape is this funny little shape like that. And I know that this point is 1, 1. This is y equals x squared, which means that the square root of y is x. All right, y'all ready? This is the hardest part for me, is visualizing this hole and hole. So let's look. This time we're going with respect to y, so we're going horizontally. So I need two different distances here. I need the whole thing, and then I need the hole in the whole thing. I need the H hole and the W hole. Does that make sense? Okay. So the area of the hole what is the radius? I'm going in terms of y though. So cubed root of y, right? Because I'm going with respect to y this time. This time I'm twisting this way. So cubed root of y squared. And the area of the h hole, the square root of y squared. Once you've got it set up, that's why the picture is so important, so that you can actually see what it is you're doing and what you're rotating. Okay, so now that I've got it set up, I can say that the volume is the integral, and I'm going to go ahead and pull this pi out. If you don't want to pull that pi out of both of them, you definitely do not have to. I find it easier than having it to plug in each time. Now I'm going from my y, so my lowest y is what? Up to what? 1. Of the whole minus the whole. But that's the hard part, right? Now it's set up, now it's a piece of cake. You just have to remember W whole minus H whole. Take the whole thing and take out the blank space. Is it as bad as y'all thought it was going to be? Yeah. All right, antiderivative here. 2/3 would be 5/3, which would be 3/5 front. 1/2 y squared. And I'm going from a 0 to 1. Three-fifths minus a half. 1/10. Units cubed. Y'all okay? Make it a little bit harder. One more example, I'll be done. Yes. Much fun now. I don't know why I just love these. I know y'all don't. I'm sorry. Find one that's going to work well for us. It's still, y'all, don't get intimidated by it. Draw the picture, draw your radius of the hole and the radius of the hole, and it'll be a lot easier for you. I just know whenever y'all see this, you're going to go, oh my gosh. Okay. The area enclosed by these two graphs is rotated about the line x equals -1. Find the volume of the solid created when the rotation happens. So let's draw the picture. -1. So I'm going to have this shape up here, but I'm going to take that shape and rotate. So it's going to have a hole all the way through it. You can look through it. It's like a telescope. Go with me? Okay. Find the hole in the hole. That's all you got to do. Every time. Hole in hole. I didn't leave myself quite enough room. Here's my shape. It looks very similar, right? But this time, the line that I am rotating around, did I say x equals, let's make that y equals -1. Let's don't start with y-axis first. I mean with a y, yeah. Make this y equals -1. Be a little easier to start with. We're going to rotate around this line. So I have to be able to see my hole and my hole. That's going to be the hardest part. You have to go to the line of rotation. Can't stop at the axis this time. So I have to go from here. And there are little formulas that I could show you to do it, but I think the easiest thing is looking at it and identifying the hole and the hole. That's the whole thing, because that's what's staying steady and that piece is wrapping around it, right? So there's a hole all the way through. So this is going to be my radius of my hole. And then this is my radius of my hole. Once you can identify that, it makes life a lot easier. Because I know I just need to do W hole minus H hole and be done with it. Let's find our intersection points first. This point is 0, 1. This point is let's go other side. This point is 2, 5. I would need the Y part if I was going around the Y, because initially this was saying rotate around this line, and that would be in terms of Y. All right, I have my points. I can see what's going on here. So what in this picture, the area of the whole circle is what? Close. That's right. From here to here is 2x plus 1. But then I've got this extra distance here. And what's that distance? But distance is never negative. I'm just talking about how the span of it. So I need to add another 1 to it. Because this line goes down to -1, right? So this space from here to here is 1. And then the area of the H hole, sorry, wrote it and didn't do it. X squared plus 1 plus 1. Which would be now the volume is just from 0 to 2. Again, I like to put my pi outside. The whole hole minus the little bitty hole. I know that we're fixing to have to go for Miss Horton, but let me just save